Hi guys, Mr. Ng here, and in this video I'm going to go through a few of the Mendelian genetics questions that you guys had out of the Campbell and Reese ninth edition book. Let's hop into it. A lot of you asked about number 10. Number 10 is about PKU. It's a recessive disease. And if a woman and her husband, who are both carriers, right, and carrier just means heterozygotes, have 3 children, what is the probability of each of the following? So let's just go real basic. Let's review that if PKU is recessive, that means big P is normal, right? And little p is going to have a PKU. And let's just go through the standard Punnett square here. So big P, little p, big P, little p. So big P, big P, big P, little p here, big P, little p here, and then little p, little p. All right, so 1 out of 4 will get PKU, and 3 out of 4 should be healthy. So part 1, all 3 children are of normal phenotype. So for A, 3 children, all normal phenotypes. So let's have 3 kids here. I'm just going to draw little faces like this. Each kid has a 3 out of 4 chance of being healthy or normal, right? I mean, 2 out of the 4 are carriers, but I don't think the book cares about that. So to find the probability of all 3 of them together, you just multiply across. 3 times 3 is 9, times 3 is 27. 4 times 4 is 16, times 4 is 64. So for part A, 27 out of 64 should be normal, right? Part B, what are the chances of 1 or more of the 3 children having the disease? Okay, let's start with just 1 kid having the disease. For 1 kid to have the disease, it's a 1 out of 4 chance, right? For 2 kids to have the disease, it's a 1 out of 4 times 1 out of 4 chance, also known as a 1 out of 16 chance. And for 3 kids to have the disease, 1, 2, 3, that's 1 out of 4 times 1 out of 4 times 1 out of 4. So that's 1 out of 64 chance, right? That's for all 3 kids. It's very unlikely, 1 out of 64 chance. So to do the math here, now you just got to add all these suckers up. So the common denominator here, let's just make it 64. That means this is 16 out of 64, and this is actually 4 out of 64, right? So I got to add up this and this and this, right? 16 plus 4 is 20, plus another 1 more, so it's 21. 21 out of 64 chance that at least one of the kids will have a PKU. Okay, let's go with part C. Let's clear all of the stuff. Right, part C. What are the chances of all 3 kids having the disease? Well, that's pretty darn easy, right? Part C. For all 3 kids to have the disease, it's 1 out of 4 times 1 out of 4 times 1 out of 4. So 1 out of 64. Fine. And then part D, for at least 1 child to be phenotypically normal. The easiest way to do it is to know that this is the probability that all 3 will have the disease, that all 3 of them. So the inverse of this, right, that means the opposite of this is to have at least 1 child be normal, right? So that's a 63 out of 64 chance, right? In the book kind of gives you a clue that all the probabilities outcomes add up to 1, right? So, um, so look, so either all the kids have the disease, or not all the kids have the disease, or having at least one kid having being normal. Make sense? So 63 out of 64. Hope that helps. Let's move on to another set of questions. Number 13. Karen and Steve each have a sibling with sickle cell disease. We already know that sickle cell anemia is a recessive disease, right? Oh, shoot.